I'm sharing my screen.
Your screen, yes.
Can you see my screen?
Yes. You do full.
Okay, one moment. Okay. Now I think you can see in the presentation mode. Okay, good morning to everyone. I am Ilaria Arduino. I am a postdoc from University of Bari, and the title of my presentation is From Oil to Microparticulate by Prilling technique using carbohydrate polymers, the case study of alginate-based loading Serenoa Repens oil as intestinal delivery system. Here, I divided my work into main parts, a brief introduction, and then I will talk about the experimental results, the preparation and the stability studies of different Serenoa Repens oil and sodium alginate emulsion, preparation of sodium alginate beads loading with the Serenoa Repens oil, and then a characterization of these beads. Tau palmetto or Serenoa Repens is a small palm tree. The oil extracted from Serenoa Repens fruits consists of active therapeutic components. Serenoa Repens oil is used for several nutraceutical or among them reduce the symptoms of benign prostatic hyperplasia by inhibiting the activity of extract is an oil, and it is used to prepare different nutraceutical or pharmaceutical preparation like soft gelatin capsules. However, some disadvantages are associated with this formulation, such as the necessity of a specialized instrument for their preparation, difficult handling the oil, and its easy oxidation, and the possible negative effect in the stomach when Serenoa Repens oil is released from the capsule. To overcome these problems, Serenoa Repens oil has been absorbed on maltodextrins, and this could be used to prepare different dosage forms, such as tablet or the capsules. However, the amount of oil absorbed on the maltodextrin is not so high, and Serenoa Repens oil is not protected from gastric environment. In order to improve the handling of the Serenoa Repens oil, it is recommended the conversion of the substance in powders. In this regard, an innovative technique is the realization of a microparticle system. Vibration technology, better known as Prilling or laminar jet breakup, has been used as a technique of microencapsulation. It is based on types of beads with a narrow dimensional range, high encapsulation efficiency, and to preserve the chemical stability of the loaded substance. Several types of polymers can be used to develop of beads, but the use of natural polymers is advantageous because of their biodegradability, biocompatibility, and not toxicity. Among them, alginate is a natural polysaccharide commonly used. For sodium alginate, the consolidation is achieved by ionotropic gelification in the presence of bivalent cations that may be calcium or zinc. Now I'm going to talk about the experimental results. And the first step of Serenoa Repens oil encapsulation procedure was the realization of formulation of only water emulsions obtained emulsifying Serenoa Repens oil at concentration of 7% with 5 different concentrations concentrations of sodium alginate solution. The stability of these emulsions was evaluated by 3 methodologies, such as visual inspection, optical microscopy, and static multiple light scattering. Visual inspection after 24 hours showed that P4 and P5 were stable, while P1, P2, and P3 were unstable. And from the graphs, we can say that when the concentration of alginate increased, the stability of the emulsion increased. These results were confirmed also by optical microscopy images, and we can see from the images that the P2 emulsion showed a sign of coalescence. Based on the previous results, 2 emulsions with different stability, P2 and P4, were studied using TurbiScan Lab expert after 4 hours. And from the graphs, we can say that panel A1 highlighted an increment in backscattering intensity on the top of the tube containing the emulsion P2, which indicate a creaming process occurring during the analysis. In the same way, the backscattering decreased on the bottom and on the center of the tube, suggesting a clarification process. Considering the studies of optical microscopy and the studies with TurbiScan, we can say that the emulsion P2 was an irreversible emulsion after 4 hours. On the contrary, the emulsion P4 was stable without any important changes. The global total scattering index confirmed also that P4 was stable, while P2 was unstable after 4 hours. However, the P2 emulsion is stable in the first hour. Therefore, the concentration of alginate of 1% was considered because it is more processable. From these results, 27 formulations were prepared, starting from 9 emulsions, obtaining varying the concentration of sodium alginate, the concentration of Serenoa Repens oil, and using 3 different flow rates, 1, 4, and 7.5 milliliter on minutes. Here, the instrument parameters used, and the gelling bath used was calcium chloride. The beads were dried using 2 different methods with static oven and freeze dried. From here, when I will talk about the beads dried with a static oven, I will call oven beads. When I will talk about the beads dried with freeze dryer, I will call lyo beads. Using a digital camera, the images of the hydrated beads were taken and the sphericity factor was calculated. A value of 0 indicates a perfect sphere. Among all 27 formulations prepared, the formulation with a sphericity factor minor of 0.08 had a perfect a spherical shape. And among these, the formulation from F1 and F9 had this characteristic. And this formulation we prepared with the alginate concentration of 1%. And the formulation F10, F13, and F16 with an alginate concentration of 2%. The other one had a sphericity factor not of minor of 0.08, so they were not considered. So from now, we used these 12 formulation for the next experiment analysis. The diameter of the hydrated bits was measured, and we can say that the hydrated bits had a diameter around 2 milliliter, and this value decreased after drying. For encapsulation efficiency, the values in a table showed that after drying in over, the value of encapsulation efficiency was decreased because with these methods there was a leakage of Serenoa Repens oil. For these reasons, the best results were that one with the alginate concentration of 2%. From here, the next analysis were performed on these 3 selected formulations. And Carr-Fisher titration is a method for water determination. This test was carried out for the 3 selected formulation in order to evaluate the efficiency of drying method, and the residual water in the bits was low, and a slight difference was present between the method used. Then, by means of quantitative GC method, the lauric acid was quantified as one of the principal components of total fatty acids. And after quantitative analysis of the lauric acid in the bits, it was converted by calculation in total fatty acid. The formulation with highest loaded fatty acid was F16 LIO with a value of 69%. And this was an interesting result reached because the formulation present in the market was the Serenoa Repens oil absorbed on maltodextrin. But for this formulation, the quantity of total fatty acid loaded was 45. For this reason, our formulation is had a higher concentration of total fatty acid loaded. A good result was also reached for F10 and F13. From these results, we selected the F16 like the best formulation, both oven and LIO, and we performed swelling and drug release study. For swelling study, a linear increment of weight bits was obtained at pH 1.2. Then, when the bits were transferred in the intestinal environment with pH 6.8, in the first 30 minutes, a reduction of weight was registered. But after this, the swelling of the particle occurred up to a maximum weight at 180 minutes. Then the beads disgregate and they disappeared at 300 minutes. About the release study, the cumulative percentage of Serenoa Repens oil revealed that the quantity of Serenoa Repens oil released in the acid compartment was very low, and most of the Serenoa Repens oil was released in the intestinal environment. These results confirmed the hypothesis reported in the swelling analysis and suggested that F16 can really be used as intestinal site-specific drug delivery system. Then the chemical stability of the oil was evaluated by means of peroxide index and the iodine number. The results in the table showed that the process did not compromise the stability of the oil. Moreover, the F16 LIO formulation was better than the oven, and its stability was also maintained over 3 months during the storage. In conclusion, we can say that we prepared a novel formulation to encapsulate Serenoa Repens oil in a hydrogel alginate bits for intestinal site-specific drug delivery. We prepared the different emulsion between Serenoa Repens and alginate solution in order to individuate the best one, and from these results we prepared the different formulation. We selected the best formulation from this analysis, and the selected formulation were the ones with 2% of alginate and with 3 different concentration of Serenoa Repens oil loaded, and further analysis permitted to individuate among the 3 formulation, and we selected the F16 16 formulation for the best. And on this formulation, we carried out swelling and drug release studies. And the drug release studies highlighted that the most of Serenoa Repens oil is released in the intestinal compartment at pH 6.8, and this new formulation could convey Serenoa Repens oil more specifically to intestine. I want to say thank you all my research group from the Department of Pharmacy, University of Bari, and I want to say thank you to everybody for your attention.
Thank you, Ilaria. Let's see if there are questions. We have one.